Hello everyone. So what I want to show you today is how do you find the network ID, broadcast ID, subnet mask, total number of usable hosts per network, and usable host range specifically for /8, /16, and /24 networks. Alright, now I strongly recommend that you have this prerequisite knowledge, especially these first three right here. Before you watch this video, because if you don't have this information down beforehand, this might not make too much sense to you. So I strongly recommend you get all these four things down beforehand, and I'll have a link in the description. That's a playlist that has all this stuff in it. You can check it out. Strongly recommend it. So, given the IP address 192.168.0.5/24, what is the subnet mask, network ID, broadcast ID, total number of usable hosts per network, and the usable host range? Okay? So, I usually start out answering this question by looking at the subnet mask. So, if you remember, Class C subnets, we divide the network's bits and the host's bits by putting it in between the third and fourth octet. So on this side we have our host bits, on this side we have our network bits. So our host bits are for the fourth octet, which is 5, and then our network bits are housed in the 192.168.0 part of the IP address. Okay? So we know that /24, if you saw the previous videos, we know that /24, the subnet mask for a /24 network, is 255.255.0, right? So that's our 24 network bits in binary. They all go through each octet and they add up to 255 in each, okay? So it's really important. That's the first thing I always suggest you do, is you separate the network bits from the host bits. If you do that, it will help you a lot in solving your problem. So another thing you would remember is that we always start by working on the first host octet that we have available to us. This is where we start doing our network divisions. It's where we start working on the network ID, the broadcast ID, and so on. So it's asking for the network ID. Now, if we look at the subnet mask, if you remember what I said in the previous video, any octet that houses 255, 255, 255, those don't change. Alright? So you're always going to put your relative to what's in the subnet mask, whatever's in your IP address in those three octets, you're just going to go ahead and put that down, because those numbers aren't going to change. Okay, 192.168.0. And now we got to find the next number. So, whenever you see a 0 in the subnet mask, that means that in the network ID, you're also going to have 0. Okay? So if you ever have a 0, right here, if you look in the subnet mask, I'm going to highlight this too, just to make it more clear. This 0 right here is saying, basically what it means is that it's going to go from 0 to 255, right? Has the full range. So that's just how it's divided. It's divided into one network. So it's going to have the full range from all the way from 0 to 255. And the important thing to realize in this is that whenever you see a 255, it basically just means that this number is not going to change, and whenever you see a 0, it means that this number is not going to change when you're writing out your network ID. Alright? And again, remember, the network ID, which I covered in the terminology video, it's your first IP address, right? The very first IP address of the subnet. Okay? So now we have the broadcast ID. Okay? In the broadcast ID, on a /24 network, let me get this out right here. So again, the same thing. The 255s are going to stay the same. So 192.168. I'm just looking at this, given the IP address, I'm just looking at these digits up here. .0. And then when this number is 0, in the broadcast ID, your broadcast ID is going to be .255. So your very first IP address is going to be, your network ID is going to be whatever these numbers are in the given IP address for the 255, 255, 255. So here it's 192.168.0. And then your last digit, where you separated the host bits from the network bits, since in the subnet mask it's a 0, we're going to make it 0 in the network ID. All right? And now for the broadcast ID, the same thing kind of applies. Basically, if this is 0, we're going to make this 255 because we are going to use the full range that it gives us in this fourth octet. So, the next question says, what's the total number of usable hosts per network? So, I suggest you have a calculator out for this. So, really quickly, I'm going to write out the formula for total hosts, or number of usable hosts per network. So, it is 2 to the power of total number of host bits in the subnet mask minus 2. So we subtract 2 because the network ID and the broadcast ID, those are reserved specifically for their, how do you say it? Basically, they're reserved and they can't actually be used as an IP address on the network, right? So you'll never have a device that's like, if you have a device connected to your network with this subnet mask and you know your network ID and your broadcast ID, like for example on this network here, you're never going to have a device with the IPv4 private IPv4 address of 192.168.0.0. Similarly, you're not going to have a device that'll have 192.168.0.255. But you can have any number in between those, and that's where the minus 2 comes from. So, total number of usable hosts per network. In this case, we have 2 to the power total number of host bits in the subnet mask. So, if you remember your binary, again, I'll just write the binary of the subnet mask down. So it goes like this. So it goes 1, 1, 1, 1, 1, 1, 1, 1. We have 8 ones. Dot. 1, 1, 1, 1, 5, 6, 7, 8. So that's 255. 1, 1, 1, 4, 5, 6, 7, 8. And then for our last octet in the subnet mask, for 0 we have 0, 0, 0, 0, 0, 0, 0, 0. So this is our subnet mask written out in binary, the whole subnet mask, right? And total number of host bits. So we have 8 host bits in our subnet mask, right? So these are, let's see, 8 times 3, that's 24. So these right here are 24 network bits, and these are host bits. So you take 2 to the power to the total number of host bits in the subnet mask minus 2. So I'm going to pull up my calculator. Oh, whoops. We have it set to scientific. We're going to do 2, let's see, what is it, to the power of 8. So that's 256 minus 2. 254 is the number of usable hosts we have per each subnetwork. So I am going to write that out here. So 254. Right there. Okay. And then finally we have the usable host range. So in this instance, our usable host range is going to be the number between our network ID and broadcast ID. So it's the numbers that are between those two, right? So our usable host range is going to look like this. So if you add 1 to the network ID, that's add 1 to the 4th octet. And if you subtract 1 from the 4th octet, you'll basically get our usable host range. So if you think about it, our usable host range is, so you can write it out like this, I believe, 1 through 254. All right, so we can use the numbers between 1 and 254. To be more specific, we could say 192.168.0. Let's see, we're going to use 1 through 192.168.0.254. All right. So this is our, I'll just say 2. Let me get that fixed up a little bit. So this is our usable host range for this given IP address, this 192.168.0.5, right? So the key thing to remember is you just draw your line, you write out the subnet mask. So you can use the CIDR notation to write out the subnet mask. Once you get your subnet mask, you realize what class it is. So this is a class C. We know our line goes here. So these are our host bits. These are our network bits. The first host octet that we're going to be working with in this case is 5. And then to find our network ID, wherever there's 255, 255, or like any 255s, whichever octet houses a 255 in our subnet mask, we're just gonna, for our network ID, we're gonna leave them the same as the IP. And then for our last digit, in the case of a /24, like the 0 in the subnet, you're just gonna make it a 0. All right. And then same thing with the broadcast ID, right? So the 255, 255, 255 in the subnet mask. When we go to the broadcast ID, we're going to do the same thing. These 3 digits are going to stay the same. And then we are going, since it's 0 here, we are going to make the broadcast ID 255. Okay? So the total number of usable hosts per network. 254, again, the formula is right here. You just count however many host bits are across the whole subnet mask. You just count however many host bits are across the whole subnet mask in binary, and then you just take 2 to the power of those. And then here I just wanted to write out this so you can see it here too. And then you just write out those host bits in your mind. You can do it. And then you just take 2 to the power of those host bits, subtract 2, and that's your total number of usable hosts. Keyword right there is usable. If we were talking about maybe just the total number of hosts, it would probably just be 2 to the number of total host bits without subtracting 2. But in the case of usable hosts, it is 254. So usable host range, it's just between this first digit because we can't use the first one in the network ID, so we just add 1 here. We can't use the last digit for the broadcast ID because it's the last IP in the network, so we just subtract 1 here. And that's where we got our 254 and our 1 right here. Okay? So really quickly, before we stop, I'm going to quickly go over a couple more questions. Alright, so I'm back. Quick snappy edit there. So I'm going to answer this question now. Given the IP address 172.42.65.110/16, what is the subnet mask, network ID, broadcast ID, total number of usable hosts per network, and usable host range? Same questions as before. So to start off with the subnet mask, we can see that subnet is a class B network. So we see that /16 right here. So what that means is we know that our subnet mask is going to be 255, get some black text, 255.255.0.0. Okay? So knowing this subnet mask, it helps us kind of solve the rest of the problems we have. So I always suggest writing out your subnet mask first. Okay? Now, given that this is subnet as a class B subnet mask, right? Because we have the /16 here. What we're going to do is we're going to separate our host and our network bits. Instead of at the last, between the 4th and 3rd octet, we're going to separate our host and network bits between the 2nd and 3rd octet right here, as so. Okay? So you're going to do this. Again, you can do it in the IP too if you want. So we have our network bits, our host bits, we have our network bits, host bits. Kind of just shows you what it looks like, right? So now in the subnet mask, notice that our numbers have changed. So now this 172.42, those 2 numbers are going to stay the same in our network ID because it's 255, right? So we're going to do 172.42. And now we see that there's a 0 at the end of our 2 remaining octets, right? Our host octets. So that means for our network ID, those are all going to be zeros, right? So again, the 255s, they don't change in relation to the IP address, and then whatever the last 2 digits are, the 65.110, they just become zeros for the network ID. All right. And the broadcast ID, so it's kind of the same ordeal. You have 172.42, and since it's zeros, we know that we can go all the way up to .255, and .255 for the last one, right? So the way this kind of works is, for example, let's say you have 172.42. What would it be? .0.255 here. If you were to add another one, what would happen is that this number right here would go back to 0 in this fourth octet, and then this octet here would become 1. So, and then it could be 172.42.1.1, and then 172.42.1.2, and then it could be 172.42.2.1, and 172.42.2.5. So they both go all the way up to 255. All right. So now if we look at the total number of usable hosts per network, all right, if you look at that, so again, if we count the host bits, and you really don't even need to write out the binary at this point if you've gotten your network bits and your host bits down, because think about it, these two right here have nothing but ones because they all have network bits, right? And these two octets here, they have nothing but host bits, and we know there's 8 bits per octet, so that means we have 8 times 2. You see the first octet here and this octet here, we have 8 times 2 host bits. So when we're finding the total number of usable hosts per network, we can say 2 to the power of, we have 8 in this one, 8 in this one, so that's 16 in total, right? So 2 to the power of 16 minus 2 is our total number of usable hosts in the network. So I'm going to quickly get a calculator out and figure that out. Okay, so 2 to the power of 16, 2 to the power of 16, 65,536 minus 2 is 65,534. So our total number of usable hosts is 65,000. So our usable hosts, 65,534. That's a total number. And then finally, the usable host range. What we're going to do for that one is, again, go back to the network ID and the broadcast ID. If you look at them, you'll see that this number right here, we can only use one if we add one, and this one if we subtract one, right? So that would be like the full range right there in a way. So what we can do, or what I'm going to do anyways, is I'm going to type out 172.42.0.1, right? Because we added 1 in the fourth octet. And similarly with the next one, we're going to subtract 1 in the fourth octet. So we have 172.42.255.254, right? So that's the range of our usable hosts for this /16 network. So I'm going to do one more problem. I'm probably going to speed through it a bit, but I'm still going to take my time and explain how I get each answer, just so you can understand a little better. All right? Okay, so I'm back again, and this time around we have the IP 7.24.384.10/8. All right? So again, like before, we're going to find our subnet mask. We know, if you memorize this, that /8 is always a 255.0.0.0 subnet mask, all right? So that's usually the first thing I look for because it's pretty easy to find. So that's our subnet mask. So on this subnet mask, this is a Class A subnet mask, right? So this network is subnetted as a Class A. So what that means is we draw our line between the network bits and the host bits between the first octet and the third octet. All right? So these are our network bits. These are our host bits. Okay? So what's the first digit we usually focus on when we do this? It's this one, the very first host octet. In this case, it is the second octet. It's this 0 right here that I'm highlighting. Right here. All right? So that's typically the first number we focus on when we're doing our subnetting problems. Okay? So now it says find the network ID. So if we look at this IP address and we look at this subnet mask, you'll notice that the 255 is now only available for the first octet, which has 7 in it. So that means 7 is not going to change for our network ID. All right? So 7 is not going to change. So our network ID is going to start with 7. Okay? And since we're working with a /8 network, we can just set the rest of the digits to 0 in our network ID. Because you see in the second octet there's a 0 in the subnet mask, we put a 0 in the network ID. Same thing, there's a third one in the third octet in the subnet mask, we put a 0 here in the network ID in the third octet. Same thing with the fourth, right? And if you've seen how this process goes so far, right, you would know that for our broadcast ID, again, we go to the subnet mask. 255, this 7 is not going to change. Now, if you think about it, the rest of these numbers, since these in the subnet mask are 0, we're going to set them to 255.255.255. And this right here is our broadcast ID for our one network. This is what our broadcast ID is. And then finally, total number of usable hosts. We calculate that by taking 2 to the power to the total number of host bits in the subnet mask. Now, this one's going to change a bit. So notice that we have 3 octets here. 3 octets of host bits, right? We use the total number of host bits, not just the host bits that are in our first working octet, if you want to call it that. Alright? So this one has, if you think about this subnet mask in binary, and I'll write it out, again, just to illustrate. So this is our subnet mask, this 255.0.0.0 in binary. So it's 1, 2, 3, 4, 5, 6, 7, 8, right? So it's like 128, 64, 32, 16, 8, 4, 2, 1, right? So that's where we get the 255. And then the rest are just going to be zeros all across the board. So 0, 0, 0, 0, 0, 0, 0. 1, 2, 3, 4, 5, 6, 7, 8. Yep. So then we're going to do another dot. 0, 0, 0. Okay, I think that's 8. And then 1, 3, 4, 5, 6, 7, 8. So this right here is our subnet mask in binary, right? So if we look in binary, how many host bits are there? How many zeros are there? Okay, there's 8 in each octet, so that's 8 times 1 times 2 times 3. 8 times 3 is 24, all right? So we have 24 host bits. So the formula says 2 to the power, the total number of host bits in the subnet mask minus 2. In this case, we got 24. So in our calculator, there's from our last problem, we'll do 2 to the power of 24. Okay, 16 million, we'll do that minus 2. So our total number of usable host bits, I'm going to write this out. We're going to do blank, is 16,777,214. That's our total number of usable hosts. Keyword right here, usable, you know. Because if we're talking about the total number of hosts, we don't subtract 2. But since we're specifically talking about the total number of usable hosts, we do subtract 2. And then finally, the usable host range. So what we're going to do is if we look back here, so the first, if we add 1 to this network ID, we're going to have 7.0.0.1, and then it's going to be 2, 7, we subtract 1 from the broadcast ID, 255.255.254. So kind of think of these addresses like a clock when you're adding and subtracting like one of the host addresses, right? Alright, and then that is how you solve this subnetting problem. Alright, and one more thing I would like to show you. I'm going to link this website in the description. It is a nice IP subnet calculator. I like it more than the other ones out on the web because it gives you much more detailed information. Like it tells you the total number of hosts, the total number of usable hosts, it tells you your broadcast address, it tells you your usable host range, it tells you your network address. You can just and it's really easy to use. So all you do is you just go to this website, which I'll have a link to in the description. You type in your IP address. As you can see, I will type in this one. I have a copy and pasted. And then you just type in your subnet mask. We have a, let's see, we have a 255.255. So we have a /8. I usually just leave this set to any. You hit calculate, and then it will show you all the stuff we just figured out doing our work. So I strongly recommend this calculator. So one thing I would like to add before I go is you're not always going to have, let me get rid of some of this. You're not always going to have an address that is a /8, /16, and /24. So sometimes they might give you an IP address like this. So I don't know, let's just make something up. Whoops, that's not possible. And 41. Okay, so sometimes they might give you an IP address that looks something like this with a CIDR notation of, let's say 27, right? And I have another video on my channel that's right after this one that's going to show you how to find all of the stuff that we went over in this video, the network ID, the broadcast ID, the subnet mask, because all that's going to change. Literally, every step that we did in this changes a little bit in when we have a network that's already subnetted, I guess you could say, right? So this network's already been subnetted. And another thing is notice that even though that this is technically a Class A IP address, it's subnetted as a Class C. So if you were to write your division line to separate the host bits and the network bits, it would go because it's subnetted as a Class C, it would go just like this. It would still go between the third octet and the fourth octet. So that's all I have for this video. The next video we're going to do a problem like this. I'm going to show you how to do it, how to get the network ID, the broadcast ID, and all that other stuff with a couple new formulas. And yeah, and then that should be pretty much all the bare minimums of subnetting covered.